Hello guys, in this video I'm going to be solving the algorithms question binary search. The binary search algorithm is a very important algorithm that every software engineer should have at their fingertips. Join me in this video to find out why. Now I'll go ahead to read the question. Given an array of integers, nums, which is sorted in ascending order, and an integer target, write a function to search targets in nums. If target exists, then return its index. Otherwise, return -1. You must write an algorithm with big O of log n runtime complexity. With the binary search algorithm, you can efficiently check if an element exists in an array. However, there's a caveat. And the caveat is that the array must have been sorted. How does the binary search algorithm work? Given an array of integers, the first thing you do is to locate the middle position in the array. Then you check if the element at the middle position is equal to the target you are looking for. If it is, you stop the search. If it's not, using the middle position as a reference, you divide the array into two parts. The part that you know will not contain the target you are looking for, you ignore that part. But the other part that could possibly contain the target you are looking for, you look for the middle position of that part also, and then you repeat the process. This is similar to you looking for a word in the dictionary. And then the first thing you do is to divide the dictionary into two equal parts. The parts that you know will never contain the word you are looking for, you ignore it. But for the other parts that would contain the word you are looking for, if you're on the page that contains that word, you stop the search. However, if you are not on the page that contains the word, then you look for the middle position of that part, and then you repeat the process. Easy peasy, right? Now let's dive into a visual explanation of this algorithm. So given an array of numbers, -1, 0, 3, 5, 8, 9, and 12. Arrays in JavaScript are zero-index based. So what this means is that the first element in the array has index 0, the next one will have index 1, the next one will have index 2, and then the last one will have index 6. The next thing I'll do is to assign two pointers, a left and a right pointer. So I'll assign the left pointer to the first position in the array, that is index 0, and I'll assign the right pointer to the last position in the array at index 6. Now the next thing I'll do is to calculate the position of the middle pointer. To calculate the position of the middle pointer, we can use two formulas. The first formula, which I'll call F1, is this. And the second formula, which I'll call F2, is this. Now, L and R in both formulas represents the position of the left pointer and the position of the right pointer, respectively. Now, why do I have two formulas? The first formula, F1, is simpler, but then it is prone to an error known as the integer overflow error. The integer overflow error could occur when you have a very large array, and then the position of the left pointer and the position of the right pointer is very large also. By the time you sum the position of the left pointer and that of the right pointer, an integer overflow error could occur. Since the integer overflow error is beyond the scope of this video, I'll include a link in the description for you to learn more about the integer overflow error. However, the second formula, F2, is not prone to the integer overflow error. Since the array we are making use of in this visual explanation is just an array of 7 elements, which is small, we would make use of the formula F1. However, in our code implementation, we'll make use of the other formula F2. So using the formula F1, let's go ahead and calculate the position of the middle pointer. So in this instance, L has value 0, and then R has value 6. So this is 0 plus 6 divided by 2. This gives 6 divided by 2, which is 3. That means I'll place my middle pointer at position 3. Then I'll check, is the element at position 3 equal to the target? The element at position 3 is 5, and the target is 8. 5 is not equal to 8. Next, I'll go ahead to check, is the target lesser than the element at position 3? The target is not lesser than the element at position 3. Finally, I'll check, is the target greater than the element at position 3? Yes, the target is greater than the element at position 3. So what I'll do is this. I'll ignore all the elements from position 3 up until the elements at the left index. Now, why am I ignoring all these elements? This array is sorted. So it means that every element before the element at position 3 is lesser than the element at position 3. And since the element at position 3 is lesser than the target, it means all the elements at index 3 up until the elements at the left pointer will be lesser than the target. So the target cannot exist in any one of these numbers. So I'll go ahead to ignore all of them. Now, the way to ignore these elements in code is to move the left pointer from its current position to the position that is immediately after the position of the middle pointer. So I'll go ahead to move this from here, and I'll move the left pointer here. So by moving the left pointer here, all these elements have been ignored. Now I'll take away the middle pointer from here, because now I have to calculate the new position for the middle pointer. So having moved the left pointer to a new position, I'll go ahead to calculate the new position for the middle pointer. Now the left pointer is at index 4. This is 4 plus the right pointer is at index 6. 4 plus 6 divided by 2. This is 10 divided by 2, which gives 5. So I'll place the middle pointer at index 5. Now I'll check, is the element at the middle pointer equal to the target? The element at the middle pointer is 9. The target is 8. They are not equal. Next, I'll check, is the target lesser than the element at the middle pointer? Yes, the target is lesser than the element at the middle pointer. So the next thing I'll do is this. All the elements from the middle pointer up until the element at the right pointer, I'll ignore all of them. Now, I am ignoring all of them because these numbers are all greater than the target, meaning the target cannot be found among these numbers. So I'll go ahead to take them out. Now, the way I'll ignore them in code is to move the right pointer from its current position to a position that is just immediately before the location of the middle pointer. So I'll take the right pointer from here and I'll place it to this position, which is just immediately before that of the middle pointer. Now I'll take the middle pointer away from here because now I have to calculate a new position for the middle pointer. So the new position for the middle pointer will be 4, which is the position for the left pointer, plus 4, which is the position for the right pointer, divided by 2. This is 8 divided by 2, which is 4. So I'll place the middle pointer at index 4. Now I'll check. Is the element at the middle pointer equal to the target? The element at the middle pointer is now 8. The target is also 8. They are the same. So I have found the target. Now I'll go ahead to return the index of the middle pointer, which is index 4. So this algorithm will return 4. Now using this same array, let's try to find if another target, 13, exists in the array. So the first thing I'll do is to assign my left and right pointers. And next, I'll go ahead to calculate the position of the middle pointer. That will be 0 plus 6 divided by 2, which is 3. So I'll place my middle pointer at position 3. Now, I'll check if the element at the middle pointer is equal to the target. The element at the middle pointer is 5. The target is 13. They are not the same. Next, I'll check, is the target lesser than the element at the middle pointer? The target is not lesser than the element at the middle pointer. Now, is the target greater than the element at the middle pointer? Yes, the target is greater than the element at the middle pointer. So what this means is I'll ignore all the numbers from the middle pointer up until the left pointer, because since this array is sorted, all these numbers are lesser than the target, meaning you can't find the target among these numbers. So I'll take these numbers out. And the way to ignore these numbers in code is to move the left pointer from its current position to the position that is just immediately after the middle pointer. So I'll move this from here, and I'll move this here, and then I'll take away the middle pointer. Next, I'll go ahead to calculate the new position for the middle pointer, which becomes 4 plus 6 divided by 2. That is 10 divided by 2, which is 5. So I'll place the middle pointer at this position. Now I'll check the element at the middle pointer if it's equal to the target. Now the element at the middle pointer is 9. The target is 13. They are not the same. Next, I'll check if the target is lesser than the element at the middle pointer, but the target is not lesser than the element at the middle pointer. Finally, I'll check if the target is greater than the element at the middle pointer. Yes, the target is greater than the element at the middle pointer. So I'll ignore all the elements from the middle pointer up until the elements at the left pointer, because all these elements will be lesser than the target. The target cannot be found among them. So I'll cross this out, and I'll cross this out also. Now, the way to ignore these elements in code is to move the left pointer from its current position and place it at the position that is just immediately after the middle pointer, which is here. Then I'll take the middle pointer away from here. And now I'll calculate the new position for the middle pointer. To calculate that, it becomes 6, which is the position of the left pointer, plus 6, the position of the right pointer, divided by 2, which is 12 divided by 2, and that gives 6. So I'll place the middle pointer here. Now, I'll check, is the element at the middle pointer equal to the target? No, they are not the same. Now, is the target lesser than the element at the middle pointer? No. Finally, is the target greater than the element at the middle pointer? Yes. So what I'll do is I'll ignore all the elements starting from the middle pointer up until the left pointer. But the middle pointer and the left pointer are the same position, meaning I'll just ignore this number, these elements, 12. Now, how do I ignore this in code? I'll ignore this in code by moving the left pointer to the position that is just immediately after the middle pointer, which is here. Now, but the middle pointer is at index 6, which is the last element in the array. meaning the left pointer will now be at index 7, which is an index that does not exist in the array. And also now, the left pointer is greater than the right pointer. So at this point, we'll stop moving the pointers. Now, since we could not find the target so far, we return -1, meaning the target does not exist in the array. Now, an important point to note is the fact that the division we are carrying out here, while using the formula F1, and also when we'll be using the formula F2 also, is integer division. So with integer division, you always ignore the remainder or the decimal. So I'll give an example. Now let's assume at a particular instance, the left pointer was at index 1 and the right pointer was at index 2. So to calculate the position of the middle pointer, it becomes 1 plus 2 divided by 2. This gives 3 divided by 2, which is 1.5. But since it's integer division we are doing, we'll ignore the 0.5. So meaning for this particular instance, the middle pointer would be at index 1. So this is it for the visual explanation of the algorithm. Now let's dive into the code implementation. So the first thing I'll do is to declare a variable that will hold the position of the left pointer. I'll call the variable left and I'll assign it to index 0. Next, I'll declare another variable that will hold the position of the right pointer and I'll assign it to the index of the last element in the array. Next, I'll go ahead to declare the while loop with which I'll move the pointers. Now, what valid condition needs to be satisfied for me to keep moving the pointers? Now, I'll keep moving the pointers as long as the position of the left pointer is lesser than or equal to the position of the right pointer. Once the position of the left pointer exceeds that of the right pointer, I'll stop the loop. So while the position of the left pointer is lesser than or equal to that of the right pointer. Now the next thing I'll be doing here is to calculate the position of the middle pointer. So just like I said in the visual explanation, we are going to be making use of this other formula F2, which is what I've implemented here. And also, like I explained, since the division we are doing is integer division, I'll make use of the math.floor method in JavaScript. So making use of this math.floor method, I'll ignore any remainder. The next thing I'll be doing is to get the number that is at the middle pointer. I'll call that number middle number. Next, I'll go ahead to check if the middle number is equal to the target we are looking for. And if it is, I'll go ahead to return the position of the middle pointer. Next, I'll go ahead to check if the target is lesser than the middle number. if the target is lesser than the middle number, I'll move the right pointer to the position that is just immediately before the position of the middle pointer. Finally, I'll go ahead to check if the target is greater than the middle number. Now, if it's greater than the middle number, I'll move the left pointer to the position that is just immediately after the position of the middle pointer. So if this while loop successfully completes without returning the index of the found target at any point in time, it means that the target was not found. So I'll return -1. Now let me go ahead to run this code. This was successful. I'll go ahead to submit. Okay, these are sparse. The next thing I would like to talk about is the time and space complexity of this algorithm. The time complexity of this algorithm is big O of log n base 2 or big O of log n base 10. Now, why is it big O of log n base 2? The reason is because with the binary search algorithm, what we are doing is dividing the array into 2 approximate halves and then ignoring 1 half. Now the question is this: how many steps will it take for me to divide an array up until the point that I can no longer divide the array? So let's assume we have an array of 16 elements. Let's attempt to divide this array. 16 divided by 2 is 8. That is 1 step. So at this point, we have 8 elements in the array. 8 divided by 2 is 4. That's the second step. 4 divided by 2 is 2. That's the third step. 2 divided by 2 is 1. That's the fourth step. At this point, we have just 1 element in the array, and we can no longer divide it into halves. So given an array of 16 elements, it took 4 steps. Now, 4 is log 16 base 2. In the same vein, if you have an array of 32 elements, it will take 5 steps. And 5 is log 32 base 2. So if you have an array of n elements, it will take log n base 2 steps, which is why the time complexity of this algorithm is big O of log n base 2. Now, why do we say it is big O of log n base 10 also? It is because as the value of n becomes very big, log n base 2 approximates to log n base 10. So we can assume that the time complexity of the algorithm is log n base 10 also. So for the purpose of this question, the time complexity is big O of log n base 10. The space complexity of the algorithm is big O of 1, which is constant space. And it is constant space because irrespective of the size of the input array, the amount of space that this algorithm uses does not change. So if you have an array of 1,000 elements, the amount of space that this algorithm will use will be similar to the amount of space it will use if you had an array of 1 million elements. Because of this time and space complexity, binary search algorithm is a very efficient algorithm. And now I hope you've seen why every software engineer should have this algorithm at their fingertips. So that's it for this video. If you like the video, give it a thumbs up. If you'd like to see more videos like this, subscribe to my channel. And if you want to get notified whenever I come up with new videos, hit the notification bell icon. I'll see you guys in the next one. Cheers.